A well-known study of 22,000 male physicians was conducted to determine if taking aspirin daily reduces the chances of heart attack. Half the physicians were given an aspirin, half were given a placebo. 6 years later, 104 suffered a heart attack who took placebos, and 104 who took aspirin suffered a heart attack, and 189 took placebo suffered a heart attack. Does it appear that the aspirin can reduce the number of heart attacks among the sample group that took aspirin? Use alpha equals 0.01. Notice the alpha is smaller than our 0.05 because it's important because we're talking about heart attacks. We want to be very serious. Lower the alpha, the higher the power of the test. So we're dealing with proportions here. So our two parameters, PA is the proportion of physicians who were given aspirin and had heart attacks. P sub P is the proportion of physicians who were given a placebo and had heart attacks. Of course, our H naught is PA equals PP, and the alternate is that PA is less than PP because we want to see that aspirin lowers the chances of heart attack, so the proportion should be lower. To check for normality, we need to have, well, clearly 11,000 is less than 5% of all physicians, should be male physicians, and N times P hat times 1 minus P hat should be greater than 10. P hat A is 0.0095 and P hat P is 180 or 0.0171. So we divide them, we plug it back in, and we need to actually plug it in like this and calculate it. So it's 103 is greater than 10, 185 is both greater than 10, so it's approximately normal. This is a two-sample proportion z-test, and it's left tail. So if we're going to do our classical method, we need to find our cutoff. So if we're using our calculator, it's in norm because it's a proportion, it's a z-test. So 0.99 area to the left, and we get 2.32. If we're using GeoGebra, we do our normal, and we put in 0.01, and we can do just the right side. And we get 2.33 or 32, same thing. So we get our, whoop, sorry, it is the left, so it should be that. So we need to find our z-score, find our p-value. There is no confidence interval because it's not two-tailed. So if we use the calculator, statistics, stat test, two proportion z-test, not two sample z-test, but two proportion z-test. And we put in our numbers here. Doesn't matter which one goes first as long as you stay consistent. Because we want to see that the aspirin is less, this first one's less, it's going to be this. We could have switched this around if we flipped these two numbers. So we get a z-score negative 4.99, so right there you should be thinking, hey, we're going to reject, because that's a very large absolute value z-score, and our p-value is very, very small, pretty much zero, approximately zero. If we're using GeoGebra, we go to statistics, and z-test difference of proportions. So it's 104 out of 1100 and 189 out of 1100. Z is there. I didn't choose the right thing. It's less than. And our P is approximately 0. Even if you change the rounding, it's pretty much 0. It's not exactly 0. Do not tell me 0. Say approximately. So my z-score is definitely in my critical region, so I reject. And the probability of z being less than that is approximately 0, and 0 is obviously less than 0.01, so we reject. So we do have sufficient evidence to reject the null, ergo we can support the claim. The proportion of physicians who were given aspirin and heart attacks was less than the proportion of physicians who were given a placebo based on our sample at alpha equals 0.01. Again, what we need to say is we can support the claim that taking aspirin, it helps reduce the risk of heart attack. That's the general idea of what we need to say, based on our sample at alpha equals 0.01. There's our proportion.